Okay, class. Today we are working on the next math lesson. We are still in Module 1. Today is Lesson 3, and this lesson is about exponents and parentheses. I don't think that's how you spell parentheses. I think it's supposed to be an A there, but we'll pretend that I know how to spell. You need pages 23 through 29 in your workbook. But right now we're going to start with our notes. So you can copy the notes with me, please, so that you have access to them, and that it's always better for learning when you write things down yourself. So let's talk about the road so far. So far, we've learned a couple things. We learned what an exponent was. We know that an exponent has a base, which I wrote in red, and there is an exponent, or also called a power, that I wrote in green. And the way exponents work is it's not base times exponent, it's base exponent times. So what happens is the x, the base, is multiplied by itself n times. And that's what we've done before. That was in lesson 1. In lesson 2, we learned 2 rules. First rule was about when we have 2 of the same bases multiplied with different exponents. So we have x to the m and we have x to the n. And when we multiply bases, the same base, remember the base has to be the same, we get x to the m plus n. Multiplying the same base means we add the exponents. Also in lesson 2, we talked about what happens when we divide bases that are the same with different exponents. And we discovered that when you divide bases with the same base with different exponents, you have to subtract the numerator exponent minus the denominator exponent. So these are the skills that we've learned so far about exponents, and these will actually help us learn the next rules that we're going to study. So let's talk about today and when parentheses get involved. So for today, let's start with this kind of problem. 3 squared to the third power. Now, initially, this might be confusing for you. You might not know what to do. You might try to, maybe add them like you did here. You might try to subtract the exponents, but neither way is what you are supposed to do. And let's use actually what we learned in lesson 1 to help us understand this. Because to understand this, you need to see that in this case, 3 squared is the base. We actually have an exponent inside of an exponent. So we're going to just look at this one first. So instead of confusing, just say this whole thing is the base. And the 3 is the exponent. So this is the base. So the base is what gets repeated. The base gets repeated. Just like right here, the x is the base, and so we get x times x times x. This time, 3 squared is the base. So you don't have to do anything except for 3 squared times 3 squared times 3 squared. And the reason I wrote it 3 times is because the exponent was 3. So it's just the base 3 times. Just like on Monday, it was x was the base, and we do that n times. Today, even though the base has an exponent, we just repeat it 3 times. We don't have to solve it first. We repeat it 3 times. So what's important to remember about this, even though the base is more complicated, it's still a base. So a more complicated base, even one with an exponent in it, a more complicated base is still a base. So let's solve this one. I did the first step here. Let's keep going. 3 squared to the third. Let me show you how we're going to combine lessons 1 and 2 to solve this. Remember, the base is 3 squared. The exponent is to the third power. So what we do, like before up here, we have the base 3 times. Base 3 times. Base 1, 2, 3 times. That's the rule for exponents. You can always do that. It's the base 3 times. The next step, I'll show you here how we can do each part separately. See how I'm making each 3 squared. When the base repeats, I'm using a different color for each of them. This is kind of stretching it out. So what happens is 3 squared is 3 times 3. This 3 squared is 3 times 3. And this last 3 squared is 3 times 3. Which, if we look at this is actually 3 6 times. So the answer is 3 to the 6th. So we can summarize and say that 3 squared to the third power equals 3 to the 6th. Some of you might have noticed that you can also do this up here, where we use lesson 2. If we go back in time to this step, you should be able to see the connection with lesson 2. We are multiplying the same base. So the rule is, when we have the same base, we can just add the exponents. That's what we did on lesson 2. So we do 2 plus 2 plus 2. 2 plus 2 plus 2 is 6. So we get 3 to the 6th. So you can, after you repeat the base, you can see that you can use lesson 2's strategy, or you can stretch everything out and just count the 3's right there. Whatever whatever method you use, you find out that 3 squared to the third power is 3 to the 6th. So question right now, looking at this solution, do you see the shortcut? So that you don't have to stretch it out, so that you don't have to do extra work, do you see the shortcut? Looking at this, do you see it? You probably see it now. Just like we did in the previous lessons, what kind of fact family do we have? If you've noticed the shortcut, you notice that 3 squared to the third power equals 3 to the 2. We take the 2 exponent and we multiply by the 3 exponent to get 3 to the 6th. That's the shortcut. When we have an exponent inside the parentheses of another exponent, we multiply them together to get our answer. That's the shortcut. So our rule, because it's always nice to know the rule with variables so that it shows what everything is. X to the m, everything to the n. We just do x and we multiply the exponents. That is the rule. Hopefully you've got that rule. Write it down, please. If you need to pause the video, you can, but I'm going to move on to let's do some examples together. Example 1, let's do some examples to make sure you have this because it can be a tricky thing and it is a little bit different. Example 1, let's do 7 squared, but everything is to the 6th power. To do this, you can stretch it out because remember the base is 7 squared. So 7 squared gets repeated by itself over and over and over again 6 times. That is exponential notation, which we learned in lesson 1. Now, what this is it's 6 7 squareds. So it's 7 squared times 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 7 squared. 6 of them, which you know because now you're going to use your knowledge from lesson 2 to say, well, all the bases are the same, so Mr. Baylor, just add all 6 2's together to make 12, 7 to the 12th. So that is stretching it out using lesson 1 and using lesson 2. Or remember the rule we just talked about. You can just take 7 squared to the 6th using lesson 3 and say it's 7 to the 2 times 6, which is 7 to the 12th. Same answer both ways. Same answer both ways. Combining lesson 1 and combining lesson 2, or just using the equation from lesson 3. Now you can use the equation always, but you should know how to do this also because this work up here proves how this works. This is the evidence for this rule. So you need to know the rule and you need to know how to make the evidence. Let's look at another example. This one we should use the rule, and you're going to see why in a minute why example 2 really needs the rule, because this time I'm doing 1 3/10 squared, but the second exponent is 10. So if I were to stretch this out, I would do 1.3 squared because this is the whole base with the mini base. The big base is the mini base and the exponent. 1.3 squared, ... 1.3 squared. I'd have to repeat that 10 times. That's a lot of writing I don't want to do. But I know it's 10 times. So instead of writing all that out 10 times, I'd need a whole bunch of 1.3s. I'm just going to use the lesson 3 rule and say it's 1.3 and multiply the exponents. 2 times 10 is 20. So 1.3 squared raised to the 10th power is 1 3/10 raised to the 20th power. So that's a couple examples we did get together. Right now, what I'd like you to do, I would like you to try in your workbook on page 23, exercises 1 through 5. So pause the video, work on exercise 1 through 5, and then we'll come back and we'll walk through them together. Okay, we're back on page 23, ready to talk about exercises 1 through 5. I like at the top of page 23, they show you the rule again so that you can remember. Exercise 1, you should have been able to do on your own. You should have known well the rule Mr. Baylor just talked about, and the rule that is written right up here says 15 to the 3rd to the 9th. I just do 3 times 9, which is 15 to the 27th. Exercise 2, the base is -2, and both exponents are 5 and 8. Multiply them together. Final answer, -2 to the 40th. Same thing for exercise 3. 3 and 4/10 is the base. I multiply the exponents together when there's parentheses like that. Gives me 3.4 to the 68th. And it works for numbers. It also works for variables. Remember, variables are just numbers we don't know yet. So we do s, and the exponents are 17 and 4. So this one is s to the 68th. Now for number 5, you're supposed to correct Sarah's mistake. Hopefully what you saw when you tried it is that Sarah made the mistake of adding the exponents. This is parentheses with 2 exponents and parentheses. So Sarah should have done this, 3 to the 5 times 7 to get 3 to the 35th power. Sarah should have multiplied. She should have multiplied. The question also asks you to use a base of 3 and use the exponents 5 and 7 and 12. Can you do it? Yes, you can, but you have to use base of 3 times 3 to the 7th. That's how you make 3 to the 12th. If Sarah wanted 3 to the 12th, she had to make 2 different exponent numbers, 2 different bases, multiply them together. That's when you add. When it looks like this, we multiply the exponents. When it looks like this, we have to add the exponents. Remember the difference. And don't worry about number 6. We won't do that one today. So that's exercises 1 through 5, but we're not done yet. There is still more to this lesson because there's another way that you see parentheses with exponents. So let's go back to our notes. We're going to add some more notes because when you're working in math and exponents, you also see problems like this with parentheses. You will see a problem where it says 5 times 8 inside parentheses, and everything is to the 4th power. Now you might be saying, Mr. Baylor, I know what to do. Just do 5 times 8, and that makes 40 to the 4th power. Mr. Baylor, I'm done. You would be done, except for we're trying to teach you a skill that can be used all the time. This skill really works well if you have 5 times 8 in the parentheses. But what happens if you have x times y? Is there another way to write this one? What happens if you have x squared y cubed z to the 4th power? It gets more complicated. So do not just try to take a shortcut and multiply 5 times 8. Please, I know that is true, but that's not teaching you the skill we want you to learn. So let's start over with 5 times 8 raised to the 4th power. Now remember, a base is still a base no matter what it looks like. So in this, the base is actually 5 times 8. And the exponent is 4. That's the exponent. And the base is 5 times 8. So you shouldn't be familiar with this after lesson 1 and practicing it. That what's happening is 5 times 8 times 5 times 8 is being repeated over and over again. Remember, exponents are just the base multiplying by itself. So that's what's happening here. The base is multiplying itself. How many times is it doing this? Well, the exponent's 4, so this is happening 4 times. So when you do this, what you get, 5 times 8 times 5 times 8 times 5 times 8 times 5 times 8. You get 5 times 8 times 5 times 8 times 5 times 8 times 5 times 8. Because we see the base is 5 times 8 and it multiplies 4 times. 1, 2, 3, 4. It's repeating 4 times because that's what it said. The base repeats 4 times. Now, because all of this is multiplication, every kind of math in this expression is multiplication, which means I can just get rid of all the parentheses and we just have multiplication. So this is going to be 5 times 8 times 5 times 8 times 5 times 8 times 5 times 8. You get rid of those parentheses. It's all multiplication. I don't need the parentheses. And because it's all multiplication, I remember there's something you've learned before called the commutative property. The commutative property tells me that if everything is multiplication, I can move the numbers around. So I'm going to move them around to put all the 5s together and all the 8s together. Now, when I do this, you should see that, wait, there's 4 5s. I see 5 4 times, and I see 8 4 times. So to simplify this, I can just write 5 4 times, not 5 times 4, 5 4 times, times 8 4 times, not 8 times 4, 8 4 times. It's a little bit different. So that is the long way to write this a different way. So this is 2 ways to write the same thing. It's how we change it back and forth. There is a shorter way to do it, so you don't have to stretch everything out, especially when the exponents get bigger. We don't want to stretch everything out. So let's look at the shorter way. The shorter way says, well, we're still going to start with 5 times 8 to the 4th. Well, let's use what we learned earlier in this lesson. What are the exponents inside here? Well, I have 5 to the 1st times 8 to the 1st to the 4th. So do you see how all I did was I added the invisible 1 exponents here? Now I can use the rule from the beginning of this lesson to make 5. I multiply the exponents. 1 times 4 and 8 to the 1 times 4. So 1 times 4 is 4. 8 to the 1 times 4 is 4. So instead of stretching the whole thing out, all I have to do is multiply the exponents, even the missing ones. So the rule for this, so this is the second rule today. When we have 2 numbers multiplied inside the parentheses, and we have an exponent outside the parentheses, we can just pass the exponent to each thing inside. The exponent gets passed inside. Let's practice that starting on page 24 with exercise 7. Try working on your own on exercise 7 and 8. Well, do 7, 8, and 9. Do 7, 8, and 9. And then come back and we will talk about it. Pause the video, please. Okay, here is my page 24, and aren't they nice? They put the rule again for you. So it's in your notes and on your page. For exercise 7, first thing you should have done, you should have said, okay, well, Mr. Baylor said put in the invisible exponent. So you should have done, this is 11 to the first times 4 to the first. So and it's all to the ninth, so I do 11 to the 1 times 9 times 4 to the 1 times 9. So you should get 11 to the ninth times 4 to the ninth. The 9 gets passed to both things on the inside. Now for exercise, this is the answer. For exercise 8, you see the exponents, so you don't have to add them. You just pass the 5 to both. The 5 gets passed to both. So we get 3, and the 5 gets passed to the 2 exponent. And we have 7, and the 5 gets passed to the 4 exponent. So we get 3 to the 10th times 7 to the 20th. Answer. I also wanted you to do exercise 9. And look, they don't. Now, if you notice the difference between exercise 7, 8, and 9, multiplication, multiplication sign, no multiplication sign. But you should know that a number next to a variable means multiply. So this is still multiplication inside the parentheses. And we can still see the exponents. So we have the base of 3, exponent of 2, and the 5 gets passed. So 2 times 5. And we have the a with the exponent of 4, and we pass the 5 to that also, 4 times 5. So you should get 3 to the 10th, a to the 20th. If you look, exercises 8 and 9 are identical except for the variable. In number 8, it was a 7, and number 9, it was an a. We do the same thing if it's variables or numbers. It's always the same thing. Exercise 10, you might want to do a little extra step and add the exponents in, where you get 5 to the first, x to the first, all to the 7th. That might help you remember how to do this. Because then we do 5, 1 times 7. The 7 gets passed to both other exponents. X to the 1 times 7 gives us 5 to the 7th, x to the 7th. That's the answer. Remember to multiply the outside exponent by all exponents inside. Number 11, try it yourself right now. You probably want to start by adding the exponents adding any missing exponents on the inside of the parentheses. Pause the video, work on exercise 11, come back. Okay, exercise 11, I asked you to please add the exponents on the inside, so you should have got, this is 5 to the first, x to the first, and they tell you this exponent is y squared. Everything's to the 7th. This time the 7 has to be passed to the 3 exponents on the inside. Gets passed 3 times to that exponent, and to that exponent. So it's 5 to the 1 times 7, x to the 1 times 7, and y to the 2 times 7. So you should get 5 to the 7th, x to the 7th, y to the 14th. Same thing for exercise 12. Pause the video, try exercise 12, and then come back when you are done and ready to check. Okay, if you're back, you should have, if you look on the inside, b, the exponent is kind of missing. You just say it's b to the first. And this time, the outside exponent gets passed to everything on the inside 3 times. So you get a to the 2 times 4, b to the 1 times 4, c to the 3 times 4. For the final answer of a to the 8th, b to the 4th, c to the 12th. That's the answers. If you got them, excellent work. If you need a little bit more help, you probably should ask a friend or ask me for a private conference. But let's look at exercise 13, because this time we have a fraction base inside with an n exponent. How does this happen? How does this work? Well, let me show you. Remember, a base is still a base. A base is still a base. So the base is x over y. So we still are going to do x over in an exponent, the base is repeated. So we do x over y times x over y, and we keep doing that over and over again, x over y. How many times? N times. So the base is still repeated. But we're not going to stop there, because what happens when we multiply fractions, we multiply straight across the numerator. So all of this is going to be x times x, keep x times x times x forever. And this is y, the denominator is y times y times y forever. How many times do we, maybe not forever, but how many times? N times for x. How many times for y? Remember, it's n times. Which means, using what we learned in lesson 1, if x is multiplied by itself n times, then x to the n is the numerator. Y is multiplied by itself n times. Y to the n is the denominator. This shows us how this is connected to the x to the n and the y to the n. So what you should see, this is this. Let's do the summary statement. When you see something like this, the exponent gets passed to numerator and denominator. Just like before, it gets multiplied. Here, we should do this. X over y to the n is x to the 1 times n, and y to the 1 times n. Let's do a little bit of practice with all the skills from this lesson on your exit ticket. Let's look at it together. Well, actually, you try the exit ticket, and then come back, pause the video, and then come back in a few minutes when you're ready for me to show you how to do everything. Okay, so you should have finished your exit ticket, and you're ready to check your answers with my work. For number 1, I'm going to use the rule we learned today and just do the exponents multiplied by each other to get 9 to the 18th. For number 1. For number 2, it's the same rule we learned today, except that this time the 3 has to be passed to everything. So we get 113 to the 2 times the 3 on the outside. This 37, it doesn't say it, but you know there's a 1 there, even if it's invisible. And we multiply it by 3 because that's on the outside. And we do 51 to the 4th times 3. So you should have got 113 to the 6th times 37 to the 3rd times 51 to the 12th. After you multiply the outside exponent by all the exponents on the inside. And they want to see you can do it with variables too. So this time it's x squared times the outside exponent, and then there's a y. It's y by itself, but you and I and everybody in the class knows that's really y to the first. And we multiply that by 3 also. And we have z to the 4th, also with the 3 passed to it. The 3 gets passed all of them. So you get x to the 6th, y to the 3rd, z to the 12th. Now number 4, they just did all variables. But you still know how to do that. It's the same pattern. You have x to the m, and the q gets passed to it, so times q. You have y to the n, and the q gets passed to it, times q. You have z to the p, and the q gets passed to that too, so you have p times q. So this might look a little bit funny for you, but it's x to the mq, y to the nq, z to the pq. The reason why it's not simpler than that is because it's all variables and we don't know what the numbers are. So if you don't know a variable, don't replace it with things. And number 5 is asking for, like what we did on practice with number 13, can you recognize what's happening? So all you have to do for number 5 is pull the 8 out. It's 4/5 and everything to the 8th. This and this are the same because the 8 gets passed to everything inside. That is the exit ticket. I hope you did well. Next, you have your homework helper that's going to help you with your homework. Remember, this is a summary of this whole lesson. So if it helps, look at the homework helper. Then after that, you have the problem set. Now the problem set is asking you to prove what we learned today, to prove in detail using the evidence. This is why I asked you to make sure you know how to do both ways. Because this shows me you know the rule. But just because you know the rule doesn't mean you can prove it. You have to be able to prove it too. If you ever want to become a lawyer or a police officer or a politician, knowing something is not good enough. You have to prove it. Or if you ever plan on having kids, trust me, just knowing the answer is not enough. Kids will ask you to prove why. So for number 1, let's prove why this equals this. And all of this page is going to be about stretching things out. So we get 2 times 3 times 7 to the 4th. So the base is 2 times 3 times 7, and it happens 4 times. So you do 2 times 3 times 7 times 2 times 3 times 7 times 2 times 3 times 7 times 2 times 3 times 7. We have the same base. This is the base, and we see it 1, 2, 3, 4 times. Now remember what I said. It's all multiplication. So it does not matter what order we put it in. So all of this is multiplication, so I'm going to put all the 2's next to each other. We have 1, 2, 3, 4 2's, and we're still multiplying with the 4 3's and the 4 7's. Remember, that is called the commutative property. I can move things around. Now I'm going to use something called the associative property, and I'm going to make groups. The associative property lets me make groups. So I'm going to do that group with the 2's. I'm going to make a 3 group, and I'm going to make a 7 group. Now, after you make the groups, you say, hey, this is 2 4 times. This is just 2 to the 4th. That's the first group. Well, the second group is just 3 4 times. That's just 3 to the 4th. Not 3 times 4, 3 to the 4th. And this one is 7 to the 4th. And if you look, I stretched it out, and I proved that this equals this. This equals this. So that's how you prove it. You stretch it out. Now, for number 2, they want you to prove it, except for this time with variables. Now, it's going to look almost exactly the same as number 1, but you just have to do it with variables. So pause the video. Oh, and number 3 is going to look exactly the same, except for that this in number 3, even the exponent is a variable. So try doing number 2 and number 3 just like I just did number 1. Pause the video, try it yourself. Come back when you're done and check your answers. Okay, everyone should be done who's joining us right now. So let's prove number 2. My job is to take this and prove how it goes into the other form. So this, the base is xyz. So I have xyz, and it happens 4 times. I see the base 4 times. Here's the base, and it happens 4 times. I'm going to use my commutative property because remember, variables next to each other mean multiply. So all of this is multiplication. Let me use my commutative property to put all the x's together, all the y's together, and all the z's together. Then let me use my associative property to make groups where I want to. And then you should see that this is x 4 times, and y 4 times, and z 4 times. And that's what I just proved. This equals this. This equals this. For number 3, it's a little bit trickier because you don't, like for number 2, I know I had to do it 4 times. For number 3, the exponent is n, so it's an unknown. It's a variable amount of times. But this is where the ... helps us, because I'm just going to do xyz times xyz ... times xyz. That ... super helpful when you don't know things. We just say, well, how many times are you going to do this, Mr. Baylor? I'm just going to write n times. And then I can still use the commutative property and put the x's next to each other, except at this time it's x times x ... times x times y times y times ... times y, z times z ... times z. So in this one, everything gets repeated. My next step, the pieces get repeated. And once the pieces get repeated, you can see, well, this, like an example in number 2, was x 4 times. In this one, it's just x n times. In number 2, it was y 4 times. In this one, it's y n times. Number 2, it was z 4 times. This time, it's z n times. And that's how you prove how to go from one to another. You just have to stretch it out. So that is all the work for lesson 3. Hopefully you follow along. Hopefully you understand what you're doing. For more practice, please see Khan Academy because there is extra practice on Khan Academy. Use the extra practice, please. We'll see you tomorrow for your next lesson.